Welcome to Math 2320. This is section 7.2. In this section, we look at further properties of the Laplace transform and its inverse. In question 1, we want to use theorem 7.2.1, which has a lot of properties, and that is the inverse Laplace transform of n factorial over s to the n plus 1 is t to the n. Factorials look like 6 factorial is 6 times 5 times 4 times 3 times 2 times 1, and 0 factorial is 1, and 1 factorial is 1. Alright, so in our problem, they want us to find the inverse Laplace transform for 1 over s to the 7th power. Well, what this amounts to is figuring out, alright, well, what's the exponent to match the formula? So 6 plus 1 would fit the n plus 1. So I need a 6 factorial on the top. I don't have one. So to keep the problem the same, I put it on the top and I divide it out at the same time. So I'm really just multiplying by 1. So the 6 factorial over s to the 7th, that part is t to the 6th. And my 1 over 6 factorial is 1 over 720. Alright, in question 2, they want us to find the inverse Laplace transform for 1 over s squared minus 1 over s plus 1 over s minus 3. So the way our formulas go, inverse Laplace transform for 1 over s is 1. Inverse Laplace transform n factorial s to the n plus 1, which we used in problem 1, is t to the n. And the inverse Laplace transform for 1 over s minus a is e to the at. Alright, so my 1 over s squared goes to t to the first power. Alright, that's this formula. Inverse Laplace transform for 1 over s is 1. And the inverse Laplace transform for 1 over s minus 3 is e to the 3t. So just a question of matching what we have to one of the formulas and making it work out. Alright, so in question 3, we have 1 over 7s minus 2. Well, I don't have any formulas that look exactly like that. The one we have is 1 over s minus a goes to e to the at. So let's see. Well, I could factor out a 7, and I'd have inside s minus 2 sevenths, split off the constant, and now I do have 1 over s minus a number. So this is 1/7 times this inverse Laplace transform, which is e to the 2/7 t. So again, manipulating what we have to something that we know. Alright, in question 4. Well, I know the inverse Laplace transform of k over s squared plus k squared is sine kt. So the top needs to essentially be the square root of whatever number is there. So let's see, s squared plus 64 is s squared plus 8 squared. So what I really need is an 8 on the top. So move the 6 out of the way, put the 8 on the top that I want, and so that I don't change the problem, I divide by 1/8. 6 over 8 reduces to 3/4, and at that point we're in business, because This is 3/4 times the inverse Laplace transform, which would be sine of 8t. In question 5. All right, question 5, we have s over s squared plus k squared. That inverse Laplace transform is cosine of kt. So let's see, what do we have? We've got a 4s over 4s squared plus 1. So let me factor a 4 out of the bottom. The 4's then cancel, and now I do have s over s squared plus something squared. And so my inverse Laplace transform then is cosine of 1/2 t, the item that's being squared. All right, in question 6. All right, question 6, I've got 3s minus 10 over s squared plus 25. Well, 25 I know is 5 squared. I know that I've got a inverse Laplace transform with an s on the top as a cosine and some number on the top over s squared plus 5 squared as a sine. I just need to make things work out. So for the 3s, I simply just move it out of the way so it's here in the front. On the sine term, I've got a 5 squared. I need a 5 on the top. So I just rewrote the 10 as 2 times the 5 and took the 2 out of the way. So the inverse Laplace transform then is 3 cosine 5t, the minus 2 here, and sine of 5t. Not too bad. All right, in question 7, we have something where, well, I don't have anything that looks like this, so let's see. Well, first off, the denominator is factorable. And, well, I'm thinking back to Calculus 2 and partial fractions. I could rewrite this as a over s plus 6 plus b over s minus 1. I just need to figure out what a and b are. So if you remember how this goes, you multiply both sides by the whole denominator. On the left I get an s. This whole thing times the a part, the s plus 6 cancels, leaving you a times s minus 1. And for the b part, the s minus 1 cancels, leaving you the s plus 6. At that point, you just pick values for s. So if s is 1, well, the a part goes away, and I get 7. B is 1. So B is 1/7. If S is minus 6, I get minus 6 equals. Well, if it's minus 6, the B part goes away. I get a minus 7. So divide both sides and I get A is 6/7. So let's see, the a went on the s plus 6 term, which is really s minus a minus 6. And the b went on top of the s minus 1. So I've got a 6/7 e to the minus 6t and a 1/7 e to the 1t, or e to the t. All right. In question 8, we get to finally put to use some of what we know about Laplace transforms. So we've got this first order differential equation. We have an initial condition. So the Laplace transform of the derivative y prime is s times the Laplace transform of y minus y at 0, which is our initial condition. So my Laplace transform of the sum goes to each piece. Laplace transform of e to the 6t is 1 over s minus 6. All right, this piece, the Laplace transform of y prime is this. 5 times the Laplace transform of y. All right, so now I'm going to call the Laplace transform of y a. And so I get as minus 2. Where did the 2 come from? The 2 was my initial condition, my y at 0. Plus 5a equals 1 over s minus 6. All right, I'm going to group the a terms together and factor out the a. Move the 2 to the right-hand side. All right, and so at that point, I'm going to divide by s plus 5. All right, so doing all that, I've got 1 over s minus 6, s plus 5, 2 over s plus 5. All right, so now where are we at? I've got it to this stage. Now I'm looking at this piece. This piece, by partial fractions, is splittable as b over the first piece plus c over the second piece. All right, same deal, multiply through by the denominator on both sides. I get a bs plus 5, cs minus 6, and a 1 on the left. I pick values of s which makes b or c be 0. If s is 6, c part's gone. I get b is 1/11. If s is minus 5, the b part goes away and I get c is minus 1/11. All right, so that's from the b and the c. These terms have the same denominator, so I need to see how do I combine these two terms. Well, minus 1/11 plus 2 is minus 1 over 11 plus 22 over 11, and so that's where we get the 21 over 11. At that point, I can find the inverse Laplace transform. I get a 1/11. This is a e to the 6t, a 21 over 11 e to the minus 5t. So some interesting things with Laplace transforms.